Hello everyone, welcome to my class. In previous lecture, we have learned about what is program, what is process, what is parent-child process relationship, and what is init process and daemon process. The structure of virtual memory space containing multi-processes. Each process has stack, heap, data, and program code segment, and how to get the process ID and parent process ID using system calls. Today, I'm going to talk about process creation and program execution in more detail. We will learn fork system call for creating a new child process step by step. Process creation and program execution. A process is the instance of a computer program. You can see the virtual memory space in the picture. The procedure of process creation and program execution has several steps. Step 1. When a program is executed, the kernel loads the program into the memory. At this point, a process can create a new process using the fork system call, F-O-R-K, fork system call. Step 2. The kernel creates the new child process by making an almost exact duplicate of the parent process. The child process inherits most of the parents. Can you guess what is the inheritance from the parent? It means parent stack segment, parent heap segment, and parent data segment. At this point, the child process is the almost same as the parent process. The program code can be shared by the two processes. Step 3. The child process can execute a different set of functions in the same program code as the parent. There is another step 3, as you can see in this picture. The child process inherits most of the parent's properties. However, the child process may not want to receive the inheritance from the parent. So, the child process uses the exact system call EXECVE system call to load and execute an entirely new program. In step 4, an exec system call removes the inheritance from the parent. That is to say, the kernel loads a new program into a process memory and create new stack, new heap, new data segments based on the code of the new program. From this point, the child process is completely different from the parent process. This picture shows the structure of virtual memory space containing multi-process with one parent and two child processes. The parent process created two new child process A and B using fork system call, and then the two child processes performed the exact system call to load and execute an entirely new program. From now on, they are all independent. Specifically, each process has its own stack segment, heap segment, data segment, and code segment. Each process executes its own program code independently. Why do many applications fork to create multiple processes? In many applications, creating multiple processes can be very useful for providing multitasking environment. Client-server based network applications is a very good example. In this picture, a network server process may listen for incoming client requests. In step 1, a network client requests to connect to parent process. In step 2, the parent process uses the fork system call to handle the client request. In step 3, the kernel receives the fork system call, create a child process for client A. In step 4, the client A can connect to the child process. Parallelly, the network server process continues to listen for another client connections. Therefore, in multiple processing environment, many client requests with multitask can be handled simultaneously. Simultaneously means at the same time. So, at the same time, many client requests can be handled in the multiprocessing environment. This picture shows the multi-process environment in case of multiple client and server-based network applications. The server can handle the multiple client requests at the same time. This system is called client and server model. The Unix and Linux operating systems provide client and server model in many network applications. For example, web client and web server, FTP client and FTP server, SMTP client and SMTP server, and so on. FTP means File Transfer Protocol. SMTP means Simple Mail Transfer Protocol. Fork system call creates a new process by duplicating the calling process. Because of parent-child relationship, the calling process means the parent. The new process means the child. Fork system call is very simple. No argument. Return type is PID_T system data type. Unix standard .header include file is needed. What is the return value according to the success and failure of the fork system call? On success, the PID of the child process is returned in the parent and 0 is returned in the child. On failure, -1 is returned in the parent, no child process is created, and error number is set properly. There are key points you have to know when you are using fork system call. After running the fork system call, two processes exist in the memory and execute the same program code, and two processes have separate copies of the stack, data, and heap segments. So each process can modify the values in its own stack, data, and heap segment without affecting the other process. This is a typical pseudocode when you are using fork system call. First, we declare a variable named child PID with PID underbar T system data type. This is typical pseudocode is using switchy sentence. According to the result of the fork system call, there are three cases: -1, 0, and default. Case -1, error is occurred. So we have to handle the error in this case. Case 0 is called for the child process. Case default is called for the parent process. After the fork system call is running, it is returned the different value according to the child process and the parent process. For the child process, 0 is returned. So the child process will be executed this part in case of 0. For the parent process, the process ID of the child process is returned. Process ID is a positive integer value. So the parent process will be executed this part in case of default. Today, we have learned about process creation and program execution in more detail. We showed the structure of virtual memory space containing multi-processes, and we have learned about how to use the fork system call through the typical pseudocode. Okay, that's it. Have a nice day and see you later. Goodbye.